Hi everyone, welcome to my channel. Today I'll explain the concept of client-server model. The definition on Wikipedia says the client-server model is a distributed application structure that partitions tasks or workloads between the providers of a resource or service called servers and server requesters called client. Usually clients and servers are on separate hardwares and they communicate over a computer network. This concept was quite confusing to me as I never think about many applications actually need a server to function well. So now let's jump into the topic. First, I will start from some real-world client-server examples and then we move towards the world of the computers. So the first example happens in hundreds of years ago when there's no mobile, telephone, or computers in this world. I want to send a message to my friend Emily who stays in another city. I may need to travel in person all the way to her city and then to her house to meet her, but that will cost a lot of time of me, right? Luckily, at that time, we still have our post office, the mailing service. I can just write a letter and put it in an envelope. And on top of it, I write where the letter to send to and where the letter is from. So I buy some stamp and stick it on top of it. Finally, I go and drop it to a mailbox near me. So my work is done now. Now the post office will take the responsibility to send a letter from my mailbox to deliver to Emily's city and Emily's house. So in this case, I'm the client of the mailing service. I request this service and the post office is the one provides me with the service. So post office is a server to me. This client-server model actually makes my life simpler because I don't need to physically go to Emily's city. The post office will do it for me. But I still need to do something to tell the server what to do, right? I need to prepare my letter and my address, Emily's address. And I need to pay for this mailing service. But after I put it into mailbox, it's end of my business, right? I don't need to care how the post office actually works to ship the mail to Emily. So for post office, the server, it needs to fulfill my request to send my letter and also need to serve many other clients like me. They have to have a robust internal system to make sure every letter goes to its destination. So they have sorting centers, they have transportation and delivery resources. It's a quite complicated system. Now let's go to another example of the ATM. Today I need to withdraw $100 from my bank account. I go to an ATM machine, then you will say, please insert your card. I inserted my card and now it says, please key in your PIN number. I put my PIN like do. Then the ATM start to serve me for different bank service, right? You ask like, dear customer, please select which service you need today. I need cash withdrawal, so I select one. After that, it will ask me, how much cash do you need? So I will give you like 100, then followed by, after the door is open, it gives me 100, say, please take your cash. Then it will ask, okay, do you need any services? I say no, thank you. Please take back your card. So in this case of the cash withdrawal, apparently I needed cash. I am the client in this case. ATM is my server. Well, a server may serve multiple services and it need to authenticate me. You cannot give $100 to random people. You have to know, okay, I have a bank account here so that I can withdraw the cash. And as a client, I may need to input multiple times to eventually get the resource I need. So, okay, now actually you think a bit deeper, you'll find that this thing actually is not as simple as it seems, right? How does it know who I am, right? You have like thousands or maybe millions of bank users for this bank. All those information can you store in a box like an ATM? It's not possible, right? So it must have a much larger system behind this ATM machine. That is a bank server. There's a bank server behind this ATM machine so that these two work together to provide me with this cash withdrawal service. Let's see what actually happens just now between the ATM and the bank server. So after I input the ATM card and my PIN, the ATM is actually communicating with the bank server for the authentication. So you will say, hey bank, I meet a person whose card number is blah, 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 and paying is blah, blah, blah. Is this a valid bank user for us? Then the bank server will reply like, yes, it's our customer. You can proceed with the services. I say, okay, I need $100. Then the ATM will ask the bank server again, like, hi bank, she wants to withdraw $100. Does her account has enough balance, right? It must make sure I have 100 to give me 100. So the server will check on itself, then it will reply like, oh yes, she's rich enough. Then after I take my cash, the ATM need to send the message to bank server again, say, okay, I gave her $100. Then the bank server will say, okay, I just deducted 100 from her account, right? I cannot take the cash, but my balance still stays the same, right? So this is the whole communication between the ATM and the bank server. So now after knows the secret bank server behind the ATM machine in front of me, immediately we know in this example, there are actually two pairs of client and server model. To me, I need some cash. ATM give me the cash. So I am the client and ATM is the server. But for the ATM machine, the bank server is its server. The ATM is the client machine that needs the server's help to do the authentication and transaction activities. So client-server model is not an absolute concept. They are actually relative concepts. ATM and bank server, as this pair of the client and server, they both have their own functionalities to work together to make sure the cash withdrawal works fine. ATM as a client is able to accept cash and read the card information, accept user input, and guide the user interactions, count, dispense, and securely store the cash, and communicate with the server. So the server in the bank, actually it listens to the client's request and sends a response to the correct client, and it stores, checks, and updates user and bank account data, right? It works with the data, and also it deals with the calculations and the logic of all the transactions. So nowadays, many types of clients share the same bank server. We have ATM software in an ATM machine. We have a cashier software in a POS terminal, mobile application in a mobile phone, and the bank website within a browser in a PC. They are all different types of softwares in different types of hardwares. So on the client side, the challenge is to make sure the services are available on all different types of this kind of platforms, and also the user experience is good. On the server side, to serve so many requests and response per second, they usually have not only a single server, but a lot of server machines work in parallel together. And the computer network connects client and server is also a very important in this client-server application structure. Okay, that's basically what I want to cover for a client-server model. So last part, I just want to show you how server hardware looks like. Servers are not magic, but just a larger computer with usually a lot more computing and storage capabilities than a PC. So there are three common types of servers: the tower, the rack, and the blade. So tower is huge in shape and it can stand alone, so you can place it in anywhere to do some separate task. And the rack and blade, usually they need to stay together with the rack within a data center. So here is a rack in a data center. Here is the rack server. You see it's wide. It's quite wide, the same width as the rack itself, and it's thin in the height. So you can rack it up, all the rack servers. And this is the blade. The blade is smaller and modular. And like rack, you have to occupy all the width. You can have many blades within a section of the rack, so it will save some space for you.